A customer asks an AI assistant about their renewal date. The model gives a precise answer, but it belongs to another company. The model was not retrained, hacked, or even wrong about the text it received. The retrieval pipeline selected the right-looking document from the wrong tenant. That is why an AI application's memory needs database security, not just model safety. We will follow one query through document ingestion, chunking, embedding, storage, authorization, retrieval, and prompt assembly. A safe local simulation will expose a cross-tenant mistake and a poison document, then repair both. You will leave with a practical security checklist for vector databases and embedding pipelines. The lab contains 2 fictional tenants, 12 invented support documents, deterministic toy vectors, mock metadata, and a local retrieval trace. No customer data, hosted vector database, production embedding model, external account, or cloud request is used. The demonstration explains control failures without providing an exploitation path against a real service. A secure design starts with the whole path. Documents are collected, parsed, split into chunks, transformed into embeddings, stored with metadata, filtered, ranked, assembled into model context, and sometimes cached. Each step creates another copy, transformation, permission decision, and failure mode. Securing only the database endpoint leaves most of the attack surface untouched. An embedding is a numerical representation used to compare meaning or similarity. It is not readable like the source paragraph, but it is not automatically anonymous or safe. Embeddings can preserve sensitive relationships, and research has demonstrated information recovery risks. Classify them with the source data, restrict exports, and keep lineage back to the original document and chunk. In the first replay, the browser sends a tenant identifier alongside the query. The retrieval service trusts that field. When the field is omitted, the shared collection searches every tenant and returns the nearest semantic match. The database did exactly what it was asked to do. The authorization architecture failed. The repaired flow derives tenant and role from the authenticated server-side session. The client cannot choose them. A mandatory filter is attached to every query, and the storage layer separately enforces permitted namespaces or collections. High-risk workloads can use stronger physical separation. Authorization must survive a missing application parameter. Next, a synthetic document enters an automatically indexed folder. It contains a plausible but false instruction and metadata that makes it look current. Because the pipeline treats location as trust, the document is embedded and ranks above the approved policy. This is retrieval poisoning. The model weights stay unchanged while the application's evidence is corrupted. Move new content into quarantine. Verify the source and owner, normalize extracted text, detect hidden or contradictory content, classify sensitivity, validate dates and permissions, and require approval before promotion. Record a digest and source version in a signed manifest. Embedding should be a controlled release step, not an automatic side effect of file arrival. An embedding index is coupled to the model, dimensions, normalization, chunking, language handling, and pre-processing rules that created it. Pin those versions. For a migration, build a shadow index, compare relevance and security slices, then promote atomically. Never mix old and new vectors casually or overwrite the last known good snapshot. Vector similarity answers a mathematical question, not a policy question. Apply access and lifecycle filters before ranking. Use calibrated thresholds, cap the number of returned chunks, re-rank when appropriate, and require authoritative source evidence for high-impact answers. A highly similar result can still be unauthorized, stale, poisoned, or simply wrong. Encrypt data in transit and at rest, but do not stop there. Keep the store on a private network path, use separate service identities for ingestion and retrieval, grant only required operations, rotate credentials, disable anonymous administration, and alert on bulk reads or exports. Never place privileged database credentials in a browser or mobile client. Deleting the source file is not enough. The chunks, embeddings, metadata, caches, replicas, backups, and generated prompt traces may remain. Give every derivative a stable source identifier. Propagate a tombstone through the pipeline, test that retrieval no longer returns the content, and document when backup copies expire. Deletion needs evidence, not assumption. A useful retrieval log records the requesting identity, derived tenant, policy filters, selected source identifiers, similarity scores, embedding and index versions, and allow or deny decision. Avoid copying full sensitive chunks into every log. Alert on missing filters, cross-namespace attempts, unusual query volume, bulk export, sudden source growth, and retrieval drift. Before release, run negative authorization tests that must return 0 results. Seed synthetic canaries for each tenant and confirm they never cross. Test hidden text, conflicting sources, stale documents, low-confidence queries, deletion propagation, credential rotation, snapshot restoration, and rollback. Evaluate retrieval separately from generation so a fluent answer cannot hide a bad search result. Choose one AI application and trace one question from user identity to retrieve chunks. Mark every data copy, trust boundary, and owner. Move tenant scope to the server, enforce it at storage, quarantine new content, pin embedding versions, add cross-tenant and poisoning tests, and prove deletion and rollback. The complete checklist and local lab diagram are on CipherVibe.